Hi, this is Rahul Nath. In this video, I'll do a quick walkthrough of Azure Key Vault and how to start using this immediately in your current project. Azure Key Vault is a cloud-hosted HSM-backed service for managing cryptographic keys and other secrets. HSM, or Hardware Security Module, is a physical computing device that safeguards and manages digital keys for strong authentication and provides crypto processing. Key Vault also supports software keys, which is less costlier as there is no physical device where the key is stored. Key Vault acts as a centralized store for sensitive information and encryption keys. It exposes this over a REST API for applications to use. Both keys and secrets are referred to as objects in Key Vault. Objects are uniquely identified within Azure Key Vault using a URL such that no two objects have the same URL. The URL consists of object type, name, and version. Object type indicates whether it is a key or secret. Object name is user specified and provided at the time of object creation. Object version is optional. When specified, it identifies the specific version of the object, and when not specified, it identifies the latest available version. Creation of a new instance with the same object name gives the new object a unique version identifier and causes it to become the current version. Azure Key Vault enables users to store and use cryptographic keys within the Microsoft Azure environment. The initial release of Key Vault supports only RSA keys. RSA is an asymmetric algorithm also known as public key cryptography. It uses two separate keys, a public key and a private key. The public key is used to encrypt the data and the private key is used to decrypt the data. Key Vault supports hardware-backed keys, software keys, and importing your existing keys. In all cases, the private portion of the key does not leave the Key Vault boundary and can never be seen or shared. Secrets in Azure Key Vault are octet sequences with no semantics. It accepts the data as is and stores it securely. Connection strings, passwords, storage account keys, PFX files make good candidates as secret. Let's take a typical application scenario of a web application using a database as its data store. The application connects to the database using a connection string. Since the connection strings are different for your development and production environment, usually this finds its place in the web application's configuration file. Connection strings are sensitive information and should not be available to everyone, even within the development team. Having it in the configuration file makes it available to everyone who has access to the deployment environment. There are possibilities of it making its way to the source control system. If the same connection string is used in multiple applications, it makes it difficult to change connection strings as it needs to be updated in all the configuration files. The Key Vault acts as a centralized store for all sensitive information and is hosted in the cloud. It is accessible over a REST API, which makes it available to any device or technology that can make HTTP requests. If you're developing on the .NET platform, then there is an official SDK available to connect to the API. Few other languages also have SDKs. See the description below for more details. There are typically two user roles that interact with the Key Vault. An administrator who manages the vault and the objects in it, the keys and secrets. A developer who accesses keys and secrets using object identifiers from different applications. Let's do a demo to see how to introduce Key Vault into an existing application. We'll walk you through how to create a Key Vault and add a secret to it. We'll then access this secret from a web application that authenticates with the Key Vault using an Azure AD application. Let's switch to Visual Studio to see this in action. The application uses a connection string defined in the configuration file to connect to the database. Let's see how we can move this connection string over to Azure Key Vault. To create a new Key Vault, let's switch to portal.azure.com. The Key Vault section under More Services lists all the key vaults in the subscription. To create a new key vault, click the Add button. The name must be unique across all the vaults in Azure. Here I choose YouTube Vault. Choose the subscription under which to create the vault. The resource group, I create a new one, YouTube group. The location is the location under which this vault will be created. Key Vault supports standard and premium pricing tier. By default, it is a standard pricing tier. Now I'll hit create, which will create the key vault. Once the vault is created and deployed, it will list down here. Select the key vault to drill into more details. This shows a dashboard for the new key vault from where you can manage key secrets and your access policies. To create a new secret, press the Add button. Choose the Upload option as manual to create a secret from a key value pair. I'll keep the secret name same as that of the connection string. I'll also copy over the connection string value as the secret's value and then click Create. This creates a new secret in the key vault with the given name and an automatically generated version identifier. This version is set to as the default of the secret. The full secret identifier is used to identify the secret in the vault. This is used from the application when retrieving the secret's value. Let's save this for later use. The secret value is hidden by default and can be seen by clicking this button. If you want to edit the connection string value, you need to create a new version of the secret. For an application to retrieve this secret from the vault, it needs to authenticate with the vault using a token from an Azure Active Directory application. Let's switch to the old portal to create an Azure AD application. Scroll to Active Directory and select the default directory listed. Under Applications, select Add and choose Add an application my organization is developing. Given a name for the AD app, here I give YouTube app. The sign-on URL and the app ID URL is not used from the demo application, so we can give in any random values. After entering valid URL values, click OK to create the Azure AD application. Once created, under the Configure tab, you can get the client identifier used to identify AD application that we just created. Let's save this value for later use from the application that needs to connect to the key vault. To authenticate with the key vault, we can use either a client secret or a certificate-based authentication. To keep this example easy, we'll use a client secret. To add in a new secret value, choose a duration for the keys and select Save. This will generate a new secret. Let's copy the secret and keep for reference from the application. Let's now switch back to the key vault in the new portal and add in the AD application that we just created. Under Access Policies, select Add New and search for the AD application that we just created. To give permissions on the keys and secrets, use the key permissions and secret permissions. It determines the different permissions that this application has with the key vault. For the demo, I'll choose all for both secrets and keys and select OK. Click Save to save the new access policy. Once the access policies is created, we can use this to connect to the key vault from the client application. Let's now switch to Visual Studio and modify this code to retrieve the connection string from the key vault. To access the key vault and the Active Directory application, we need to add two NuGet packages. Let's go to the Manage NuGet Packages and search for Key Vault. This NuGet package helps access the key vault, the secrets and keys in it. To access the Active Directory application, let's add the Active Directory NuGet package. Search for ADAL, which stands for Active Directory Authentication Library. The Key Vault client requires a token from the AD application to authenticate this application with the Key Vault. The Key Vault client from the NuGet package that we just added takes in a function as its constructor parameter. This is where we need to authenticate with the AD application and return an authentication token. We will use the client ID and secret that we had saved earlier. This is used to authenticate with the AD application. The client ID and secret mode of authentication forces us to place these values in the application or in the configuration file. But this is what we are trying to move away from in the first place. In another video, I'll show how to use a certificate to authenticate with Key Vault. This removes the need of placing any secrets into the application itself. But for now, let's use the classes exposed from the ADAL NuGet package to connect with the Key Vault using the client ID and secret and retrieve the authentication token. The Key Vault client exposes a method getSecretAsync to retrieve a secret from the Key Vault given an identifier. Let's use the identifier that we had saved earlier to retrieve the secret. Once we have the secret available, let's replace the existing call to the configuration manager with the secret that we have retrieved from Key Vault. On execution, the application now uses the connection string from the Key Vault to connect to the database. It retrieves the number of contacts in the database and returns that to be displayed in the UI. We can now remove the connection string from the configuration file. Looking back, we now see that the application does not need to use a connection string in the configuration file. Though it hardcodes the client ID and secrets for now, we'll see in later videos how to remove this as well. Hope this helps you to get started with Key Vault. Feel free to drop in the comments if you need any further information. Thank you.